An input device allows data to be entered into a computer system, either manually by a human, such as with a keyboard or mouse, or automatically by a device like a light or temperature sensor. Input devices enable humans to interact with computers through methods such as text, voice, or touch. The OCR A-level specification does not require you to know any specific input or output devices, nor how any of these actually work, but you must be able to recommend appropriate devices for specific situations and justify the choices. So let's look at some common types of input devices. We've got a keyboard to enter text and numbers, mice to control on-screen pointers, controllers to input commands in games, microphones to capture sound, scanners to copy images or text digitally, cameras to record photos or videos, remotes to send wireless control signals, touchscreen, which is both an input and an output device to sense touch input, barcode scanners, which reads product barcodes, trackpads to detect finger movements on laptops, biometric scanners, verifying identity using features such as iris or fingerprint, graphics tablets to input drawings or sketches, card readers to read data from credit cards or debit cards, pedals to input via foot press, buttons to trigger a single command, and sensors to detect changes in environment such as light, sound, temperature. Now we're going to take a look at some of the less common types of input devices, starting with an OCR scanner. OCR stands for Optical Character Recognition, and it converts printed or handwritten text into a digital format that a computer can process. Similarly, there's the OMR scanner, which is optical mark recognition, which automatically detects marks made on documents such as multiple choice tests or lottery tickets. And then a concept keyboard, which is a programmable keyboard where each key can be customized to perform a specific function. Then there's a sip and puff switch, which is an assistive device that lets users control a computer by blowing or sucking air through a tube, and an accelerometer, which detects and measures the movement or acceleration of an object, for example, counting steps on a fitness tracker watch, and an altimeter, measuring how high an object is above sea level. It's mainly used in vehicles like planes, but can also measure the flights of stairs that somebody has climbed on a smartwatch. A gyroscope measures orientation and rotational movement, such as sensing when a phone is being turned. A magnetometer detects the strength and direction of magnetic fields, with a compass being a common example. And finally, a GPS receiver uses satellites to provide accurate location information in real time. Now we'll look at output devices. Output devices take data produced by a computer and convert it into a form humans can understand. Output devices present the results of processing, such as displaying visuals on a monitor, producing sound through speakers, or printing text on paper. Here are some of the common types of output devices: a monitor to display visuals on a screen, speaker to output sound, printer producing a physical copy, lights or LEDs showing status or alerts, projectors to project images onto surfaces, an alarm to make a loud warning sound, touchscreen, we remember that's an input and an output device to display and respond to touch, a fan to provide cooling airflow, and headphones to output private audio. Now let's look at three less common types of output device, starting with a plotter, which produces line drawings on paper using automated multicolored pens, often for high quality graphs, charts, maps, or technical drawings used by architects. A braille display is a refreshable device with braille cells that allows visually impaired users to read text by touch. And finally, an actuator is a type of motor, often paired with a sensor, used to move or control mechanisms such as opening a valve, turning a wheel, or operating a door. A common exam question is to provide a scenario and ask you to justify suitable input and or output devices. Let's look at suitable input devices for a smartwatch. Firstly, there's a touchscreen to let users tap or swipe to navigate apps and menus. Then it will have an accelerometer to detect movement and steps for fitness tracking. Also, a gyroscope to sense wrist rotation to adjust the display or control apps. And also a magnetometer working as a digital compass to show direction. There are many more suitable inputs for this example, such as heart rate sensors and GPS receivers too.